This is the first tutorial calculation video for Newton's law of universal gravitation. If you haven't watched the theory video yet, I recommend you go and do so unless you're quite comfortable with the topic. Welcome to TLDR. Question. Calculate the gravitational force of attraction between the Sun and the Earth, given the following values. The universal gravitational constraint G, radius of the Earth to Sun orbit, mass of the Earth, and mass of the Sun. We should also remember that our equation for gravitational force is equal to the universal gravitational constant G times by mass 1 times by mass 2 divided by the radius between the two objects squared. I recommend you go ahead and pause the video and have a go at doing this calculation by yourself. Okay, let's go ahead and talk about the solution to this question. All you have to do is plug in the values given to our equation and solve for force. We can find that the force is equal to 3.6 times 10 to the 22 newtons. Pretty easy. Alright, so we'll move on to our second question. Now we're going to calculate the gravitational field strength or gravitational acceleration of a satellite orbiting the Earth at 40,000 kilometers. Once again, we have the universal gravitational constant G, the radius of the Earth, the radius of the satellite in orbit, and the mass of the Earth. So once again, go ahead and pause your video and give this question a go. Now to solve this one, first of all, we have to calculate the total radius at which that satellite is orbiting. So that's going to be the radius of the Earth plus the radius of the orbit. And this is equal to 46.37 times 10 to the 6 meters. We can now go ahead and apply our universal gravitational equation, which is F equals the universal gravitational constant G times m1 times m2 divided by the radius between the two objects squared. When we apply our initial values, we can solve to get force is equal to 0.185 times the mass 2, or the mass of our satellite. We can then go and divide through by this mass to get the expression F divided by mass is equal to acceleration. Therefore, we have found that the acceleration of our satellite is equal to 0.185 meters per second squared. We have to remember that acceleration is a vector and you'll lose marks for not specifying the direction. So in this case, we should say that the acceleration is actually equal to 0.185 meters per second squared towards the center of the Earth. Okay, that's the end of the questions. There will be more on the universal gravitational constant in the future once we've covered Kepler's laws. Thanks for watching.